Welcome on Talk about platform engineering. Normally, this is a talk that I do together with Grace, but unfortunate for you, she is not able to join today, so you have to deal with me. I'm Maarten Vandeperre. I'm specialist solution architect at Red Hat, specialized in application development and AI. Nowadays, everything has to be in AI as well. And in the application development space, I'm responsible for the development use of OpenShift, the entire middleware landscape, runtimes, and nowadays the platform engineering side of things as well. So a couple of years ago, or decades maybe already, we had the rise of the cloud. It was fun. Ooh, the clouds. Yeah, don't worry, don't bother about the Disney references. Yeah? Better? Okay, let's try it. Otherwise, just tell me. So you had, ooh, the cloud. And developers thought it would now bring more flexibility, more responsibilities to them because they were blocked, they were frustrated, they were slowed down by infra and ops people. They had to wait for VMs, for example, for new databases. It could take up to days, weeks. And now the cloud would solve everything. But in the end, cloud development for most developers won't generalize too much. Look like this. So what will we talk about today? It's first of all, how did we get in that state? And let's talk a bit about developer struggles. Then let's discuss some core concepts of platform engineering as well, of which the developer portal and the developer platform are core components. And then it should bring benefits for developers, and let's discuss these as well. And then I'll showcase you a way of working on a platform and Backstage as a developer portal. So what happened? Why did we get these frustrations with the move to the clouds? Well, we as developers asking for more flexibility to our management caused management to think that now that we gave them a cloud console, they can do way more. So we introduced shift left movement, where a lot of responsibilities that were part of the ops team are now pushed towards developers. But then as developers, it's now of, oh shit, networking, how does that go? What about resources? What about all these databases? And then if you open a cloud console, it can be on Google, can be on Amazon, can be on Azure, you see 1,000 components. What do all these things do? I don't think we're too happy with all these flexibilities, all these responsibilities that are now part of the development job. Because it's not just dev anymore. It was dev, it became DevOps, FinOps, nowadays MLOps, up until abbreviations that can't fit the slide anymore. So development work is getting more and more complex. What happened? Well, in the past, let's imagine the time that dinos still were able to speak. We had, as developers, two responsibilities: writing code, and then building the code and throw it over the fence, throw it over the schutting, to the ops teams that then maintained the entire operational lifecycle of the application, that then maintained the entire infrastructure on which the applications would run. You had, generally spoken, happy devs, up until the nagging on the ops people that everything was too slow, and overloaded ops people. Then with the rise of the cloud, you got the shift left movement. Many of these responsibilities were now pushed toward the development side. You got overloaded with the cognitive overload on the development side of things. And you got confused ops people, because if you give a cloud console to a development team, up until where do we have the responsibilities for the ops team? Does the ops team still need to maintain things in the cloud console, or is it all the responsibility for the developers? It's not a clear barrier anymore. And then, as already mentioned, tools, tools, tools. Way too many tools are part of this cloud landscape, cloud era. Let's zoom in a little bit into these tools. You now have the Cloud Native Compute Foundation, CNCF, which is a foundation that's working around everything that has to do with cloud native development, mainly focused on Kubernetes. This is a subset of all components that are available to build developer platforms, development environments. To show you that already this subset is very complex, very big, we've introduced an Wally, Waldo, depending, or even Charlie if you're French speaking, into the slides. I'll give you some more homework, but if you want to search for it, we will share the slides, and then you can search for it in the evening. If you want to search for it in the evening, close your eyes, because, spoiler, he's over there. We really introduced him in the Cloud Compute Foundation slide. So what are development struggles that are going hand in hand with this cloud-like, cloud-native era? First of all, you have the CI/CD tooling. When you were working with, for example, WAR or EAR files, deploying in a JBoss, in a Tomcat, maybe even a Glassfish server, you now had to learn containers. With containers, you discovered Docker or nowadays Podman. Then you had microservice, mini-service development, and with a couple of these services, a couple of these applications, you need orchestration. So you had to learn Kubernetes. And then you think, finally there, Kubernetes was already a hassle to get acquainted with. And then you see the cloud-native grocery store, and you think, oh. So that's a first burden. The second one is containers. It's not just running a container. It's already starting from the baseline. Which underlying operating system do you choose for your container? Which packages do you want to install? In the past, I was not thinking about having VI, Vim, Nano in an image. That would be an issue. Having curl, wget, and all these things in an image, it could be an issue. But these are all things that can be exploited by attackers. It's all increasing your attack surface, so you should remove these. How do we configure it on all our environments? How do we do our build pipelines? These are all questions that come along with container development. So in the end, it's not just running a container. I already mentioned the attack surface, but security and regulations are now a big concern as well. Let's be honest, not really for us developers, but for the organization in general, it is. Like, for example, SBOM extraction. Which dependencies do we have inside our code bases? There's a software supply chain. This is the one submitting the commit, especially in open source world. Really, the one that's submitting it. Can we sign this? Can we sign our container images, that we work with container images that we built that were not tampered with? And these are all things that I will showcase in the demo as well. Nowadays, in the AI era, this is getting more and more important as well. Because, for example, who's using AI-generated code at the moment? Not too many people? Okay. Do you check as well the libraries that are getting introduced by this software? Yeah, okay, that's already a good thing. Because most of the time I get a lot of hands people using AI, but not checking which dependencies are getting injected through this AI quota, which can as well enable vulnerabilities. And then authentication, authorization, especially if you go to, for example, the agentic AI parts, as Stefan Janssen quotes often, the S in MCP, to build agents, stands for security. And I think that's a good quote to showcase how little security is embedded in AI at the moment. Then we have other struggles like key person dependencies. Creating environments can still take too long, or with drowning in scripts, and maintenance costs are sky high. So in the end, moving to the cloud looks more like this. If we check, okay, IntelliJ, you'll see you have solutions for this in the platform engineering part as well, which I'll showcase later. So it was a good coincidence that I had this now. What developers are saying, they have with the shift left movement an increased workload. They have a lot of pressure from the digital transformation, and this was even taken before the rise of AI. And there's a lot of requirements to learn new skills. If you want to see why, just open one of the cloud consoles. You have to make decisions in these components. The list of components is huge. Then on the other hand, if you now ask developers, do you want to do ops as well? Do you want to be real DevOps? I think 42% is saying yes, 42% is saying no or no in a less polite way. So how to overcome these struggles? Hence the title of the talk. I don't think it's a surprise, but platform engineering can help over here. First of all, what is platform engineering? You have official statements, but in the end, it is enabling self-service and enabling abstraction layers on infrastructure and application configuration. 2, 3 core concepts that define platform engineering in general. They often put it in combat with DevOps, but that's not entirely true. Because platform engineers are making use of DevOps principles to build the underlying platforms that they provide to developers. How does this go? In the ideal world, we start from the development side of things. We go to developers and ask them, hey, which capabilities do you need on a platform? Important notice, start with requesting this on your developers and not build a platform and push it to your developers, because adoption rates will be rather slow if you do this. So we go to our developers and we ask, which capabilities do you want? If you're building mini-services, microservices, they will need an orchestrator like Kubernetes. They will need a container registry, some CI, CD tooling, and so on. Then with this list of requirements, this recipe, you go to a platform team and the ops people of the platform team. And you now start baking your own platform. For every capability that developers are requiring, you have a dozen of components that can give you this capability. For example, if you think about CI, you have Tekton, you have GitLab, you have GitHub, you have the good old Bamboo, you have Jenkins, and so on. For every capability, you have a lot of components to choose from, and that's then part of the platform team and the ops people from the platform team to build this into a platform and deliver it to your developers. So how does it look like? You request capabilities, you bake a platform, but then you still have an issue. For example, we have Jenkins and GitLab as CI. You still have a couple of application interfaces then to work with, because you have to go to the CI pipeline for every mini-service, microservice that you're maintaining. You have documentation sprawl, a lot of documentation pages in which you can't find your documentation that you're looking for. So a lot of pages that you need to bookmark to find your way into the infrastructure inside the information of your organization. And this is what we call the bookmark hell. So this already shows you that purely developing a developer platform is not sufficient to make the life of the developer easier. So for that, there's a second component, and it's a developer portal, which now acts as a single point of contact, a single pane of glass, a single interface on everything that's inside your organization's landscape to do your daily job. And we'll come back to that later in the demo as well. First of all, the platform, which we call the IDP. If you're reading about platform engineering, make sure that you know what the abbreviation IDP means in that context, because sometimes it's used for the developer portal as well, so that you're not confused. So the IDP is a centralized collection of tools, services, and automated workflows into one platform, so already pre-integrated for you. It acts as a service layer, and it provides self-service capabilities and abstraction layers on the infrastructure on the one side, and then application configuration on the other side. If you would like to have an example on this, for example, if you go to Cloud Console and you, as a developer, want to request a database, first of all, even in the SQL space, you already have some options. Then you want to initiate it, and it's how much memory, how much RAM, what about networking configurations? To be honest, these are things that I don't want to care about. So what the platform then can do, it's put an abstraction layer on top of it. Just say you have two options. You give it a name, and you give it a t-shirt size. And then the t-shirt size is mapped behind the scenes to your cloud operations team. That they say, hey, it's that much memory, that much RAM. And you as a developer just have to define a name or a t-shirt size to get started with a database. Then the portal, short, it's the single interface on top of everything that's living in your development ecosystem. What are now the benefits for devs? It's yet introducing something else, so it should come with benefits as well. So where we had the silos in the beginning of devs and ops, we now introduced, and maybe let's not call it a silo, but in the image, a silo now, which is platform engineering, platform teams. I often get the question, should this be new hires? It doesn't necessarily need to be. Because you have platform engineers at the moment, it is an added value that you have them in your organization. But I think a platform team can only succeed if you have cohesion in between the other teams as well. For example, on the dev side, let senior developers be part of the platform team. To, on the one hand, tell the platform engineers, the platform team, what are the pain points, what are the hurdles that development teams see on a daily basis, to list the requirements like this. And in the other direction as well, to advocate for the platform, to be platform champions in the development teams, to increase the adoption rate. and to avoid shadow IT within all these teams. Because yes, shadow IT sometimes easy to set up, but hard to maintain, and it's not that stable at all. And on the other hand, you have the ops people that need to integrate all these components for you. So a platform team in the end will be 80, 90% ops-related profiles, combined with some development people, and even maybe some platform engineers. If you have to position it to your management, there are quantitative dev benefits as well, that you can say, hey, if you introduce platform engineering now, you will see a return on investment. It will cost you money in the beginning, because you will need to set it up. It's not coming for free. But in the end, if you make the life of the developers easier, if you make it more efficient, you will gain money out of it in the end. It's not Red Hat, it's not IBM related, it's Humanitech, so you can believe the numbers, it's not marketing material. There are some challenges and some bad things with it as well. One of the challenges is you still need to build it. It's not something that can come off the shelf, because all these requirements, all these capabilities are dependent on the team that's using it. You need to align on processes and standardization within the company, because if every team is working on its own way, and you have a dozen of teams, it's getting hard to get them into one framework, into one portal, into one platform. So that can be a challenge as well. And then as well, see how far you want to go with these platforms in the beginning. If you have a team of 4 people, don't go to a full automated, fully abstracted platform that takes you in 70, 80% of your software development time, but start small. Because some people, when they start on platform engineering, want to start too big. And then you can have issues that you spend too much time in the beginning and it's not delivering value. Because generally speaking, even 1 or 2 automation scripts into a Git repository can already be the beginning of a platform. A platform is there to give self-service and to provide abstraction layers. Which tools are there to help? Well, first of all, we have the reference architectures. This is as well one from Humanitech, and most of these reference architectures divided into subgroups or planes. For example, a developer control plane, monitoring, logging, security, resources, and so on. Another one is the tooling landscape from platformengineering.org, which is already a bit more extent, a bit more specific. And next to that, we have as well the one from the Cloud Native Compute Foundation, which you saw in the beginning, the Where's Waldo slide. That was on the platform side of things. Now, on the portal side of things, I think at the moment we have one big project in this space, which is Backstage. It's now part of the CNCF landscape and donated, so started by Spotify. And it's an open platform for building developer portals. It's highly customizable because you can enable, disable features through plugins. But the disadvantage of Backstage is that the enablement or disabling of plugins is done through changes in the source code in the React application. So at Red Hat, we see often customers failing to go to the full upgrade cycles because it's a nightmare to get it upgraded every time because these plugins start failing, because your customizations are failing, and it's a burden. Something that we saw at Red Hat as well, and it's for that we created, all open source as well, a downstream project, which is Developer Hub, which enabled the concept of dynamic plugins, that you now could configure Backstage through YAML definitions, that you could enable, disable these plugins through YAML definitions, and that you can configure these plugins, you can guess it, through YAML configurations. We do everything open source and community first, but the developers from Backstage were a bit resistant for us doing this huge refactor into the source code of the Backstage project. So for that, we started a midstream project in between Developer Hub and Backstage, which was called Janus. Nowadays, the configuration, the code changes to enable the dynamic plugins are becoming part of the Backstage project. So if you search for the Janus open source community project, you'll see that it's deprecated because all these changes are getting pushed into Backstage. But let's not show this to a slide where we can demo this too. So how will the demo look like? Well, we have a developer platform which is built upon OpenShift. If you're not familiar with OpenShift, it's Kubernetes with a dozen, 50 to 100 components already integrated for you that you don't have to integrate it. But in the end, it's a vanilla Kubernetes engine under the hood. It's not a fork from Red Hat. We have some CI tooling, Tekton, GitLab Jenkins, DevSpaces as IDE, and Quay as image registry. And on top of that, we have Backstage as a developer portal. We have downstream Developer Hub, so forgive me if I use Developer Hub instead of Backstage in the explanation. In the end, it results into the same product. So if you're working with Backstage, this is the default homepage in which you already see some capabilities. All these things are configurable. If you have other plugins that you enable, menu will change. And logo, color codes can change to your organization's color schemes and styling themes as well. An important one is already the software templates, the golden paths, as they are called in the documentation as well. These are blueprints for applications. So if you need to create a new mini-service or microservice, what was happening in the past for the employers where I worked for, it's that service is doing similar things. I'll copy it, I remove some code, and I have my baseline to start from. But then you forget to remove some code, and in half a year, it's, what is this code doing? I don't know, but it has to be there, so it has to do something right, so leave it in. So your technical debt is increasing. You remove too much, and suddenly it's, why is the service not working? Yeah, we have to look. Or, on the deployment side, you copied these parameters as well, and you forgot to rename a couple of them. And suddenly, in a staging environment, the application you copied from is crashing because you're overriding it, deploying over it with your new application. So for this, you now have blueprints that standardize these core applications, these core baselines, and that you can bootstrap with some parameters. First of all, how do you define such a template? Again, it's all YAML, and I don't know if it's readable. Yep. And it has mainly two sections. First section is parameters, where you list these are all the components that I want to parameterize. For example, in the database project I told you about on the platform side, could be a name, could be a t-shirt size. And then you have a steps outline, and it's all the steps that need to happen when you want to bootstrap, when you want to initiate this project. So let's now introduce this into Backstage. There are already some components created for you, some software templates created for you, but you can easily adjust a new one just by adding that template.yaml file. Now it's there, and it has some default code as well. Default code is coming from the skeleton, which you can see as a default Spring Boot, Quarkus, Micronaut application, but doesn't necessarily need to be Java. It can be Python, can be Scala, can be Go. It is not really restricted to a programming language. The important thing is to get it found, inserted into Backstage, that you have a catalog info definition, in which you have annotations to enable or disable sub-project menu items, as you will see in a minute, and in which you have some metadata descriptions. As you can see, you can use parameters inside these configurations. These parameters are not only allowed inside this catalog info file, it can be there in your Java files, for example, as well. That by this, you parameterize your package names, that the name that you give to this application is reflected in the package name as well of the resulting project. If we then choose to bootstrap one of these templates, you get in a form layout. So let's do here JSpring application on this cluster, but let's maybe change this to a cluster that doesn't exist. I already bootstrapped it, and I want to make sure that I'm not breaking the configuration I have at the moment. And some restrictions on the naming. I choose an image registry, can be internal into OpenShift Kubernetes, but I'll choose the external one, Quay. I choose GitLab as a repository location, can be GitHub, can be the Atlassian suite as well. I review it, and I create it. Now these steps that I defined into the template are getting executed. And normally we should now have a game JSpring application in our code base. You'll see that we have 2 repositories now. It's because we have the tendency to split GitOps code, so deployment code from source code can be in one repository as well, depending on the flavor that you prefer. And then within this repository, where you have all the Docker configuration, the pipeline configurations, Maven, and maybe Gradle, no, Maven configurations, and the base source code to start from. All in a couple of minutes, all standardized, all stable normally, that you can easily start developing. As then bootstrapping through CI pipelines, Argo CD can take a couple of minutes. I've already done this before the session. So now that you have created a repository in GitLab, you as well have a component, a software component in Backstage. This is now the starting point to start developing on this software project. You see these submenus. These are enabled or disabled depending on the annotations you have in the catalog info YAML file. For example, you have a topology layout, all red at the moment, so the CI pipeline is working or failed. This is how it's looking like on Kubernetes. So I can already start investigating why the dev part, the dev environment is not up and running. It was not what I expected, to be honest. But let's blame the demo gods. You have issues here that can be a link to Jira, ServiceNow, Trello, to have the outline of what's happening within your sprint, if you're working Scrum or Agile-based, that whenever you have to wait, for example, for the CI pipeline, that you can see, hey, I still have to review this ticket. This is still open. I can work on this, and so on. A convenient one is a list of pull requests, merge requests. That's next to your CI pipeline as well. Because how was it for me in the past when I was more active in software development itself? It was, I developed something, I have a pull request open to finish my work. I had to nag at the daily stand-up, hey, can you look at my pull request? Nobody reviewed it. During lunchtime, you have to push again. And after 2 or 3 days, your pull request was approved. Or then you get a comment. You could apply the comment, but meanwhile, you start already something else. It's not that efficient. Now, if you have to wait 1 or 2 minutes for your CI pipeline, you can easily already have a look at which pull requests are open. Then you have your CI pipeline, and indeed it failed. On signing the image, okay. What this pipeline is doing, in the beginning, I mentioned already the trusted software supply chain. It's now adding security on your software landscape if the pipeline runs properly. So it starts with git clone, then you package it, nothing exotic at the moment. You do some source code scanning. For this, we're using SonarQube, and you do some unit testing, integration testing on it. Then first step, the one that's failing at the moment, is to sign the image. Why is that a necessity? Well, you have, for example, Docker Hub, on which you can find some images. But if you hear security people talk about it, it's often called Vulnerability Hub as well. Because a lot of images over there are images that are containing vulnerabilities. We have in Belgium a pen tester, Philippe Bogaerts, who is doing some workshops, some presentations around it as well. And he has, for example, a container image that contains ransomware and cross-shell attack abilities. That image, even if it's in the title, be aware it is tempered, is, I think, for now, running on 100 applications. And with this image, he can take over the entire Kubernetes cluster. So make sure that even if you have a wrong mirror configured in your entire application landscape, that you're only using the images with the correct signature, the images that you built with your CI pipeline. Then Regarding regulations, nowadays, yeah, SBOMs are getting more and more important. So software bill of materials, what's all inside your applications, something that we extract here and upload as well. ACS is something that you don't have to remember now, but this is just a tool to scan what's all in my container image and how many vulnerabilities are there. For example, in the AI landscape, which Python libraries are there and which vulnerabilities do they contain. And it checks as well the environments where to deploy to for vulnerabilities so that you can see, for example, with the log4shell attack that we had, the log4shell vulnerability, which environments are still having that vulnerability. And then we do a resync to Argo CD. Argo CD is a GitOps tool that is using your configuration as Git code, for example, application versions, and then making sure that your Kubernetes cluster is aligned with these configurations. Often we see people deploying through Kubernetes APIs. The disadvantage of doing that is that whenever the API call fails in processing mode, it can still be that you get an acknowledgement, so that you think from your CI pipeline that it got deployed, but in the end, it is not running on your system or not running on your environment. And then you can have tricky questions of, this is not showing up from your key users, and you're thinking from your CI tooling, it's deployed. Argo CD now is, you have your configuration, this is how the cluster should look like. I will try or retry to apply this. Like for example, here you see with the CI pipeline that failed, I don't have the container image, so I'm in a degraded state. The cluster is not in a state that I configured into Argo CD. Then documentation. It's listed here on the project, which is already a plus. But you have a centralized documentation page here as well, where you can have application repository documentation, but you can have as well coding best practices, coding standards documented over here. Now with AI, I would say you can introduce the concept of including all documentation that you have in Backstage. But yeah, then you have to do a lot with AI, a lot of reworking, because all this documentation is written in Markdown files. What we often do at customers is that these documentation pages be starting points to go to the entire documentation landscape that you have. That'd be a starting point that you can say, hey, for Java applications, we have this, and this rules, as you can find in this documentation page and this documentation page. Because, for example, on SharePoint, on Confluence, if it's not Markdown related, it's handier to work with visuals and all these things as well. So don't force everything into Backstage, but let Backstage be the starting point. That's the most efficient way of dealing with it. And then one I really like as well is the API listing. On the project itself, on the individual project, it's less of a value, I think. Although it's already handy that you, for example, can view the source, and it's then going to definition here. It's open as Swagger UI. If security is set up properly, you can already try out the API call. But the most convenient component is the listing over teams, organizations. This can be protected with RBAC, so role-based access. So if you have APIs that should not be visible for the entire organization, you can shield them. But what do I really like about this is, in the past as well, when I had to integrate with an API of another team, yeah, he developed it. You can check with him on Teams. And Murphy's Law, whenever you need to check with that other developer that developed that API, he's on holiday, his kid is ill, you can't get a hold of him. Here you can already search for the API, you already have the first line of documentation, API definitions at your disposal. You don't need to find people that developed it to get some information. And let's see. And, yeah, of course. Mm-hmm. Yeah. What is the question? So I don't get the question. Yeah. Yeah, and that's the last step as well, a dependency overview. So that's the last step that I want to show. This is rather limited, but you can go as far as you want. So this is just the API used or developed by that team, but you can increase the depths. Okay, yeah, it doesn't show up here properly, but for example, already for databases, database schemes used by that API, used by this and this application. What was used in the past is API keys were a bit used as well to see who is subscribing on this. There's not a visualization of how dependencies within the organization lay. And it's even going on developer level, team level, so you have more fine-grained control on this dependency. Then, yeah, just like documentation, you have the learning paths. An important visualization here as well is TechRadar. For example, hey, we want to use Cassandra, we want to use MongoDB as a database. Nowadays, maybe Milvus, Weaviate as vector databases. That now your infra team can say, hey, it's already on our radar, but we're still investigating on how the security is, how mature it is to really use it on an enterprise-grade level, but be aware we're already looking for it. On this radar, you can see that they're already investigating it. It's no need to ask them with 20, 30 developers what the status is. As well, Java 11. You can have applications that are still running on Java 11, but can be in the on-hold column. So please don't create new applications with Java 11. We already have a couple of newer versions that you should use. And then another cool thing, but for this we have multiple solutions into the Backstage project, it's to have some automation flows. For example, here we have a greeting workflow that you can guess it. It's all YAML based. If I have some network connection now. Yeah. So again, YAML based, some conditional steps, workflow management, where you now can say, hey, the user or developer using the portal has to choose language, then you greet depending on the language, and you have a result. If you now run it, and let's say Spanish, next, run. Now that workflow is getting executed. And if you have some decent network, normally the response should be there. But this is now a dummy example. Okay, let's maybe do it like this. All runs. Okay, normally if everything works well, you there have the greeting in Spanish. But this is now a dummy example where it can be used for is to have an abstraction layer, for example, on Ansible or Terraform automation scripts to easily start automating stuff without having the knowledge about Terraform, Ansible, that the automation teams deliver it through some kind of workflow management over there. For example, changing firewall rules if you want to enable a database, that you can select which is the underlying operating system, on which server the firewall rule can be changed, maybe with a condition upon approval from a networking team. So that's in a nutshell what you can do with Backstage on a developer platform. Maybe one important thing there as well is Backstage doesn't bring you anything of this. You still need to develop it behind the scenes. Backstage is still just a view on top of all these things. By introducing Backstage, you will not have proper CI tooling. You will not have CD tooling. You will not have complete processes. You will not have software templates. All these underlying components need to be there before you can get value from Backstage. That's important to note. Backstage is not the only one. You have Rodi, which is now integrated more and more into the Backstage one as well, and Creatix, I think, as the bigger competitors for Backstage, but Backstage by far is the biggest one. So with this, I would say, have a look at platform engineering developer portals and let them guide you towards the future. Let's not run away from it with the shift-left movement that we had. We now have more abstraction layers on all these choices that we have to make, so development life should become more easy now. And I told you that I would give you some homework as well. We've seen a lot of things here in platform engineering, so for example, the cognitive load reduction, developers that can be helped with, the platforms, the portals, the golden paths. And maybe important to note as well, the last slide will be my LinkedIn profile. On the golden paths, you have one disadvantage. That's whenever you bootstrap that application that is there in the wild, with microservice alike, you don't have a central place to maintain it anymore. So now I'm building as well a software architecture where you have a centralized place to store main configurations, for example, Java versions, base Docker images, and push it through the initiated applications. But more on that when that post is polished. Resources, other blog posts that you can read, not only from Red Hat, not only for IBM, so not marketing related. Netflix is having some. You have from SNCC, you have from Spotify itself. You have platformengineering.org, which has a platform conference as well, which has some interesting movies and blog posts about it. And you have some blog posts and tutorials that we've created as well. Maybe the most important one, if you want to get your hands dirty on this as well, is the last one. This is the installation of Developer Hub on the OpenShift sandbox that you can get on developers.redhat.com. It's all for free, even no credit card requested. And then you have an interaction with GitHub, with the GitHub pipelines, and GitHub code repository to bootstrap some software templates. And always feel free to reach out if you have some issues with these tutorials. With this, I want to thank you, and these are the two people that you can contact if you have questions. But for example, these tutorials, Grace you can contact for platform engineering and for Open Liberty. And you can contact me if you have questions around Quarkus or the developer portal like Backstage in general. With this, I want to thank you, and if you have questions, feel free to shout.